Hello, thanks for having me. My name is Gilad Ben Shach. As mentioned, I'm the Director of Strategy and Partnerships of Quantum Machines, and I'd like to tell you today about the Israeli Quantum Computing Center as a use case, as something we are both managing at Quantum Machines and also effectively a customer, and really share with you some of the things we've learned about opening a dedicated quantum computing center, and in particular, a dedicated quantum data center as part of that. So first, a little bit about the Israeli Quantum Computing Center. It opened its doors just a month ago at the end of June 2024. It is the world's first dedicated quantum data center. And so what we mean by this is that it is effectively a data center with classical and quantum components, but it is built intentionally to be a quantum data center, not adding quantum to existing classical infrastructure, but really building from the ground up a cutting-edge computing facility that has both classical and quantum infrastructure and really optimized for hybrid quantum classical computing. The investment comes from, in large part, from the Israeli government, from the Israeli Innovation Authority, as well as directly from Quantum Machines to bring the center together. So how are we bringing the vision for the future of quantum computing to life? First of all, at Quantum Machines, we really believe that the future of quantum computing holds a few key components. One, the need for dedicated quantum data centers, which involve tightly integrating all the compute resources, both quantum and classical on site. Second, as part of this, you really need heterogeneous quantum and classical computing resources working together, where they share a strong, unified tech stack, which starts at the control hardware and works all the way up through the cloud and applications. And by open and transparent here, we say to empower breakthroughs. What we really mean here is two things. One, the open part, you can access the devices at any level you'd like, from higher level applications to gate to pulse level control. And by transparent, we mean that it's not just a black box. You can really, as you need and want, you can get information on every wire and every filter that's put into the system. So it really is like having your access to your own quantum computer in the lab, from the extent of the access you get to it, with the extra bonus that, unlike a typical research lab, you have all of the on-prem HPC tightly integrated, which would be typically out of budget to do in a standard research center. So from this, we're then building a truly unique hands-on experience, but also expertise at Quantum Machines in how to architect and implement the quantum computing and HPC integration. So we want to, as I mentioned, want to share with you what we've learned through this process. And so I'd like to share with you three key design choices that we have made in building the Israeli Quantum Computing Center. First up, we decided that we needed to have a unified stack from the control hardware up. So what you can see on the left is what, it's your left. What we have not done is have different quantum computing resources, each with its own API, which has to be accessed separately. Instead, all the quantum computers in the center use the same tech stack from the control hardware upward, which means that from the user's perspective, there's one API, there's one way to program it, and you can use the various devices. And when I say various devices, so we have superconducting qubits from Quantware, we have photonic device from Orca, and we also have what we call an open cryogenic testbed. This is a fridge fully set up with control electronics from Quantum Machines that is effectively available for rent and for different purposes. At the moment, we're really excited and lucky to have a Rigetti Novera, a 9-qubit device in the system, and we're providing special access to select partners to do some novel research on that device at the moment, and really being the first users of the Quantum Computing Center. But as we said, so on top of the different quantum computers which we have in the center, and there's a possibility to add additional systems over time, everything is unified by Quantum Machines OPX 1000, by our control platform. I won't go into detail on this. There was a whole talk yesterday, and obviously if you'd like to learn more, please come by our booth before the conference wraps up, and happy to share more about it. But it's powerful, versatile, and in our opinion, really leading control platform to then be able to control all of the different QPUs beneath it. And so by having this, it allows for uniform development and a unified programming experience for the user, whether you're writing in Qua, which is our low-level pulse level programming language, or through the compilers we offer, you're writing in a higher level gate language. In any case, it all compiles down in the same way, no matter which backend, which processor you are ultimately using. And if we take the same idea and we look at it now from both our perspective as the data center owner, the data center manager, but also from the user's perspective, it was clear to us that having this unified control layer, assuming it is powerful enough, is really a natural choice to make. Right? And a few reasons for this, just to really emphasize, are one, it allows for uniform integration of diverse quantum computers. As mentioned, we have superconducting qubits and a photonic device, but we could also support any other modality in the same framework. It allows for best-of-breed performance enhancing software tools. So if you wanted to add layers on top, right, we have partners here from Classique, from Q-Control, et cetera, want to add their software on top, you only need to integrate to the control layer. And from there, the integration to the different hardware platforms is trivial and is done automatically. And finally, it allows for, therefore, from our perspective, easier upgradability and serviceability of the entire platform. If we want to replace one of the devices with a next generation device over time, we don't need to change the entire stack. You don't need to modify suddenly your code from the user's perspective. It all runs, and from our perspective, it's easy to change out each component separately. And so that's the last point, is really emphasizing the user experience, that you need to develop your code once, and then you can run it on the different devices. The second key design choice we made was to have a multi-layered approach to the classical compute resources that we have and how we integrate that with the quantum computer. So what we're not doing is having just a quantum computer and an HPC center, and we say that they're tied together. Instead, we are adding 4 layers of classical compute. You see them here. At the top, you have the cloud layer. On the left, you have the HPC cluster, which is on-prem. On the right, you have the OPX 1000, which is our control and has a layer of classical compute built inside. And then you see the tight integration to the DGX Quantum, our partnership with NVIDIA. And we'll talk a little bit more about all of this on the next page. I will call out additionally that QBridge, what you see in gray on the right, which is our product together with Partech, it allows for SLRM extension to include quantum computers. So the entire center, both the classical HPC and the quantum resources, can all be run through your SLRM job scheduling. So why are these different layers important? Really, it comes down to the different timescales of your work and what you need. So we start from the left of the nanosecond timescale and work all the way up to larger than milliseconds. So starting at nanoseconds, which are important, this is within the lifetime of the most challenging, most demanding qubits. Really what we mean is qubits with the shortest lifetime. You need to be able to do work on a nanosecond timescale, and for that you can use the FPGA, the real-time sequencing, and Turing-complete computation we enable within the OPX 1000 on what we call the pulse processing unit, the PPU, the core of the product. So that's for your really fast timescales. As you start to get into error correction, then you can probably get to microsecond timescale, and for that we have the deep integration with NVIDIA for the DGX Quantum, which is a Grace Hopper superchip tightly coupled to the OPX 1000 to allow for such low latency. As you go up to the millisecond timescale and you're starting to get into the world of hybrid quantum classical work, then we have the on-prem supercomputer, which allows for more versatility and much higher capacity than we have at the lower timescales. And as you get to even larger timescales, then you have access through a tight coupling to AWS locally in Israel, so that you can have as much cloud resource as you need to do your pre-post processing, et cetera, which doesn't necessarily have to be on-prem. So again, this takes you from a world of quantum computers as a snowflake, where quantum computers are a rare, unique addition to your existing HPC center and don't really fit into the rest of the framework, to instead making your quantum computers, we say in quotations, just another XPU resource. So you have your CPUs, you have your GPUs, and you can also have a variety of different QPUs, and they're all treated equally. They're all scheduled in the same way. They're all virtualized. And so even the QPUs now are virtualized, which allow for shared time. As you get to larger and larger QPUs, you can imagine splitting up a large QPU into smaller pieces for different experiments. And all the different components are tightly integrated through the QBridge as a middle part for the scheduling and breaking apart your jobs as they go. So to bring this all together into one picture, you see here that at the top, there's a user development layer. And so you can program in Qua, which is our low-level SDK. You can use our libraries. You can write in CUDA Quantum. You can use Classic as our software partner for the QCC, and you can use their libraries. You can write in Qiskit or Circ or other high-level programs, or also use Orca's dedicated libraries. All of that, you can then write your code through our cloud layer, host your Jupyter notebook, or wherever it is you choose to program, and then you send your job, which goes through Slurm, including the extension, and can get allocated to the various classical and quantum hardware uniformly and as needed at the center. As mentioned, this is done with a lot of different partners. We mentioned Quantware and Orca providing the actual quantum devices today. And as mentioned as well, we're lucky to have, at least at the moment, a Rigetti device installed as well. NVIDIA is core to enabling that middle timescale, and we're very excited about the DGX Quantum. Partech is working with us on the Slurm integration, AWS is providing the cloud level, and Classic is doing the software, including the user management, to really be able to access a portal to use the quantum devices at the IQCC. To summarize some of the different services of the Israeli Quantum Computing Center and how you can use the center, first of all, we have the cloud-based quantum computing. So this is what we've been talking about, but you can now experiment with your different quantum algorithms. You have access to both classical and quantum resources. You could develop new applications and test them in this environment. You can gain deeper access and freedom to operate than would be previously possible. If you didn't actually have these on site, as we mentioned, you can get access to all the core information about the device, about the wiring, et cetera. We're happy to share that. We're happy to work with you. And so it's really as close as you can get to having the system in your own lab while using it remotely. And again, this is supported by both the quantum computing and HPC experts who we have on-prem, and we're ready to work with our customers, with partners, both in academia and industry who want to come use it. As well, mentioned briefly, but I think it's important to highlight the on-premise cryogenic testbed. The idea is that this is a fully wired, fully set up fridge together with the OPX 1000 and soon also the DGX Quantum. And you can bring your device and you can test it in this advanced cryogenic environment. It is capable of hosting large devices. We say on the order of up to 25 superconducting qubits, but also doesn't have to be superconducting qubits. And we're really excited that for someone who is either looking to experiment on the integration with the HPC, you want to experiment on using the OPX, you just don't have enough fridge space and you need to borrow fridge space for some amount of time, whatever your reason is, this system is available to you as a service. And we think that's an important part of the combined center. And finally, the center is also going to engage in consulting and education programs really designed and dedicated to help organizations of various levels and various forms prepare for and leverage quantum computing technologies with the big emphasis on how to play in with the HPC part as well. So with that, if I wrap it up, I think it's the key takeaway is that the IQCC, the Israeli Quantum Computing Center, is pioneering the idea of a dedicated quantum data center. It's designed around our vision of future of quantum computing, and hopefully if you share that, you can learn, and you're thinking of opening a similar center, hopefully you've learned from this, and we'd be happy to share more about our learnings and more about what we want to do. We think this is something that we'll need to see more of around the world in the coming years. That we do believe firmly, and not only because we are a quantum control company, but fundamentally believe that the quantum control system is a critical choice in how you build the center, and that it not only because of its effect on the performance of the actual devices you have, but also because of the architectural implications and how you do your integration with the classical systems you have on-prem. And so to be able to really have multiple quantum computers integrated nicely and efficiently with the classical resources you have on hand, we really believe that a unified, strong control layer is important for that. And so finally, we really invite you to learn more about the center, to talk to us about your plans. We want invite you to leverage the unique experience that we've built in this groundbreaking journey to either join us on it or to do a similar journey on your own, and we'd be happy to follow that with you as well. With that, thank you for your time.